Today I'm going to show you part 2 of solving systems of equations by elimination. Make sure you've watched part 1 before you get here. We're going to start with a review of what I did at the end of the part 1 video, and that is I can subtract here, but I'm going to multiply one of these just by 1 and one of these by -1 so that my y's will cancel out when I add. So I'll get 8x plus y equals -16. And this one, I'm going to multiply every term by -1, so I'll have a positive 3x, a negative y, and a positive 5. And then if you remember, I'm just adding, I have 11x, my y's cancel out, and -16 plus 5 is a -11. Finish it off, and I get an x equals -1. And then I'm just going to put that -1 back in the top equation here. And I'll get a -8 plus y equals -16, add my 8, and I'll get y equals -8. And my solution as an ordered pair. Now this series of using arrows is what we're going to be doing throughout this entire video. Look at these two equations. Can I multiply one of them by a -1 and have my x's or my y's cancel out? No. So I've got to take it up a notch. I'm still going to use my arrows. I'm still going to multiply. But I have a choice here. I'm either going to multiply the top row by a -5 so my x's cancel out, or I'll multiply my top row by a -2 so that my y's cancel out. Does it matter which one I do? Not at all. So I'm just going to use the smaller number. I'm going to multiply the top by -2, and I'm going to keep the bottom the same. So I'm just going to put a 1 there that I'm multiplying. So then I'm going to get, let's see, a -2x and a -2y. Where's my negative? There it is. And my -14. And then here I'm just keeping this the same. And as you can see, my y's are now going to cancel out when I add. So I'll get a 3x. Those cancel out, equals a -6 divided by 3. And x equals -2. Then finally, I'm going to put it back into one of the two equations. It looks like this one is the easiest one. So I'll have a -2 plus y equals 7. Add 2. Y equals 9. Now, I will tell my students they need to show all this work when they are doing it on a worksheet. I want to see it all just in case there is a mistake, then I can go and diagnose the problem. Which equation would you keep the same and which equation would you multiply? Well, tell you what, I'm going to keep this one the same. So I'm going to just say times 1. And I'm going to multiply this one. But what would I multiply this one by? Well, I think if I multiply by a 3 times 2 is 6y, and my y's would cancel out. Sure enough, sounds like a good plan. And I'm not even multiplying by a -3 because they're already opposite signs. So the first one is going to be, same as it was, 7x minus 6y equals 9. And then the next one, I'm just multiplying by the 3. So 15x plus 6y equals 57. All right, add 7 plus 15 is 22. So 22x, my y's cancel each other out. And 9 plus 57 is 66. Okay, finish it. 22 divided by 22, x equals 3. All right, I'm going to use the bottom equation because it doesn't have a minus sign in it. So 5 times 3, which is our x, plus 2y equals 19. 15 plus 2y equals 19. Minus 15 minus 15. And I have a 2y equals 4. Easy. Y equals 2. And if you don't believe me, put it back in those other two equations and see if it works for both of them. Okay, what are you going to do here? Well, hopefully you're going to see that I can't keep one the same and multiply the other one to get anything that looks like that, unless you want to multiply with fractions, but who wants to do that? So this time we're going to take it up a notch, and we're going to multiply both equations by a different number so that one of our terms cancels out. One of the methods you can use is the same sort of thinking that you use when you find common denominators. So I'm going to use the word common denominator. We're not doing anything with fractions, so don't freak out. So right here, 3 and -2, what would be a common denominator of that? A 6. In other words, what could they both multiply up to? What about here? What could they both multiply up to? 4 and 5, 20. And it doesn't matter which one you're going to go for. I'm going to go for the first one as long as you do it. All right, so here we go. Since the x's already have opposite signs, I don't have to worry about a negative. So I'm going to just multiply this top one by 2. That way I'm going to get a 6x. I'm going to multiply the bottom equation by 3, and that way I get a negative 6x. Let's show you how this works. All right, multiply everything by 2. Remember everything, including this term after the equal sign. See, I just doubled everything. That keeps my equation balanced. The next one, I'll multiply everything by a 3. So I get a negative 6x. I get a negative 15y, and I get a positive 30. All right, x's are going to cancel out. I get a negative 7y. I get a 28. Finish it up. And I have a y equals negative 4. I mean, at this point, everything's exactly the same as what we've been doing before. I'm just going to put it back into one of those equations and solve. So 3x minus 16 equals negative 1. Plus 16 plus 16, 3x equals 15, which means that x equals 5. All right. Well, I mean, I stepped it up a notch, but it wasn't that bad, was it? All right, how would you solve this? And there's a couple different ways to do this. I could try to get my x's to both be 10s. That's the common denominator for those two. And I could make the y's equal 24. You notice how both 12 and 8 would multiply up to be 24. So, I don't know. I think I'll just do the first ones and get that over with. So I just multiplied the top by a 2 and got a negative 10x. And I multiplied the bottom one by a 5. I got a positive 10x, so my 10x's will cancel out. And again, it doesn't matter if you had tried to cancel out the y's instead. We would get the same answer in the end. And then divided by negative 16, y equals negative 1. Let's go ahead and put it back into, I don't know, the top one, sure, 2x, or not the top one, the bottom one, minus 8 times negative 1 equals 0. So 2x, that's plus 8 equals 0, minus 8, 2x equals negative 8, divided by 2, x equals negative 4. Now, if you had done it the other way where you got rid of the y's first, you would have gotten the negative 4 first and then used it to find the y equals negative 1. Okay, pause the video, do this one on your own, get as far as you can, and then watch the video and see how my work matches up with your work. Well, I'm looking at this and I can multiply, again, I have a couple different options here. I can multiply both the top one by 8 and the bottom one by 3, and my y's will cancel out. I look at the 10 and the 15, I go, they both multiply up to 30. And that is smaller multiplication. So if I multiply this by 3 and this one by 2, then I got my 30s. My x's are going to cancel out. Now, if you did the y's, that's fine. It's okay. We'll get the same answer as long as your math is right. Here we go. So negative 10x times 3 is negative 30x. Then I get a 9y, and I get a negative 90. Here I get a 30x, and a negative 16y, and a positive 90. Whoops. So these cancel out. I'll get a negative 7y, and I'll get a 0. That's cool. Negative 7 times what is 0? 0. All right. So now let's go ahead and put it back in. Again, it doesn't matter which one. So I'm just going to do, I think, the second one maybe. 15x minus 8 times 0 equals 45. So these cancel out. 15x equals 45. Divided by 15, x equals 3. So my final answer is 3, 0. Now, what I noticed in this video is I realized that not once did I have you in the last 3 problems multiply one of the equations by a negative, but sometimes that has to happen so that you can get opposite terms to be able to add. All right, you've seen it all. I've given you the hardest ones you can see basically for elimination, and as you notice, hopefully they weren't that hard. Your turn. Go have some fun.